Hi, this is Ed Kohler with Extreme Networks, and we're back to you with the final video on our initial series on setting up a Fabric Connect node and associated services. In our first video, we set up our node. In videos 2 and 3, we went through some show commands and illustrated how we could extract information out of the fabric and out of the network element itself. In video 3, we went through a detailed tour of the link state database, which is really a series of extended show commands specific to the ISIS link state database. Videos 2 and 3 are probably two videos you want to revisit after looking at this video, because the three are very tightly conjoined and will really give you a comprehensive guide as far as how to troubleshoot and diagnose the fabric network. We then went in and provisioned out layer 2 and layer 3 virtual service networks, and now that we have the virtual services in switch 4, we are now going to go ahead and do a little bit on CFM and the background of what it is and what it's intended to do. So if you will recall, in the L2VSN video, I spoke about the fact that we kind of took away a lot of the tools that hackers would use to enumerate a network, being the fact that Fabric Connect itself should be viewed as a black hole from the IP protocol perspective, and that really IP, and even VLANs for that instance, are a event phenomenon that happens at the event horizon, which is the user to network interface out to the client or subscriber community. So we take away a lot of visibility because it's all based on Ethernet switch paths, BVIDs, and VMAX. So while we do this and we take away the tools from the hackers, we also have to realize that we take it away from network administrators as well. CFM effectively gives that tool back to network administrators, and there's a whole suite of tools that are in CFM, and we'll kind of talk about them. But we're going to use two in the video just because of time constraints, L2 ping and L2 traceroute, and we'll use those tools to determine network traffic path information out of what we built thus far. It's always wise to get a set of definitions here. First of all, Connectivity Fault Management, CFM, is defined as 802.1 AG within the IEEE. It's an actual standard. It really is not formally associated with SPB, although it's often used in conjoint, and obviously within Extreme Fabric Connect, it will always be used in a conjoined fashion. There are three definitions. First of all, the maintenance association. This basically sets the domain of diagnostics, if you will, and it gives a list of all the maintenance endpoints or maintenance intermediate points, and we'll talk about that briefly as far as what's configured within the domain. We have our maintenance endpoint, and if you remember in the first video, we actually set up our MEP ID to be number 4. And these points are basically diagnostic points which send and receive CFM frames through a relay function. And they'll drop frames according to a specific hierarchy. And we'll talk to that as we move forward throughout the video. And then we have the maintenance intermediate point. And I want to emphasize there's really no difference between a MEP and a MIP otherwise than its function topologically within the database. And what I mean by that is if you're starting your diagnostics at one point, it's a MEP. And then any nodes in the middle of the network that participate in that diagnostic function would be interpreted as MIPS. And on the other end of the network, you'd have another MEP. So that's how MEPs and MIPS work. On the other hand, you could go to a point intermediate, and let's say you have some user to network interfaces off of that, and start diagnostic functions. Then for that separate diagnostic function, that node that was a MIP in the previous exercise is now a MEP. So the function shifts according to the diagnostic exercise, and I think that may be obvious over the video, although we don't have a very big network, so you'd kind of have to play around with this a bit in order to understand what I'm talking about. But the whole important point is that there is a limit in visibility according to the domains in the hierarchy, and that's best illustrated by the following diagram, where we have the customer level, which is typically level 7 or 6, and we have 6 as a default that we use. And the customer basically has visibility end-to-end for their diagnostics for connectivity, but really no visibility to any of the lower level hierarchies, which would be the provider level. And as you recall, our level was 4 and under. So everything that happens underneath the customer, the edge network, would have no visibility to. And we kind of term this as two separate things. When you see the configs and the command lines, you'll see the CMAC, which is the client MAC or the customer MAC boundaries at the edge of the network, and then SPBM. Our video will focus primarily on the functions of SPBM. We really don't have CMAC set up in this video. This is a better diagram to kind of illustrate what we're going to do in the lab. And it might not seem obvious at first, but hear me out. So here we have these hierarchies and these domains set out with service OAM, trunk OAM, link OAM, and we see these service boundaries. We can also see that we have our UNI link, which would have the CMAC on this side. So SPBM is really everything we're concerned about here within this boundary. We have 3 elements. We have the backbone edge bridge on each side, that brings 2, and then we have the backbone core bridge in the middle. Now, for the purposes of our demonstration, we're going to run everything from switch number 1. And from switch number 1, we'll be diagnosing and using CFM to switch number 3. And the reason why we're doing that is because we know that switch number 1 and switch number 3 are the quote-unquote active switches in this network. So for the purposes of our exercise, backbone core bridges will be switches 2 or switches 4. So that kind of gives you a relation to how this is all going to work against the network topology. Again, we're going to focus on layer 2 ping and layer 2 trace route, but also realize that there is a trace tree function, which allows us to do a kind of an equivalent to the show unicast tree command that we executed in the show video in video 2, and then the layer 2 trace mroute command, which is actually able to trace multicast routes. Again, there is the concept of these CFM level hierarchies. We use level 6 at the CFM CMAC level. We're not going to use that. We do not have it enabled in this lab. So everything we do is going to be SPBM CFM using level 4, which again will stick within the constructs of this diagram that I've shown. Now conceptually, we're talking about monitoring the link and the service in this construct, and you'll see that as we move forward. Now, as you will recall, we did set up CFM in the initial video when we set up the node, and we did that as part of the script. If we did not do that, I said it was a relatively simple thing at that time to do, and here are the commands to do it. I want to go a little further though, is that this isn't even required. According to the note here, you can see that level 4 is the default level, and you can have all MEP IDs as ID 1 in actual practice. That's not an issue at all. It's really the BMACs that give us our unique identifiers, so everything would work just fine. You could literally do a run SPBM and select defaults for everything in a new install, and everything would come up. So that's the beauty of it. Being a lab, I have specific MEP IDs set up and everything else, and we're even going to have a special trick for you as we move forward into the video in the command line. And down below we see 2 examples of CFM that we're going to focus on in this video, L2 ping and L2 trace route. And we can see that we execute them against the BVID values and also the router node name of the specific switches. And switch 3 will be our target throughout the CLI demonstration. Okay, so here we are, we're back in our lab. We still have our command console into switch 4, and we need to telnet over to switch 1. And again, what we're going to do is execute pretty much all of the CFM exercises between switch 1 and switch 3. So in order to go further, let's get our command line up and running. And I just want to show something here that I thought I would change ahead of time, but I really couldn't let sit is, first of all, as I did a show CFM SPBM, you can obviously see that we're at level 4 and all of the other switches are at level 4, but I used a MEP ID of 4. And I was actually a little bit absent-minded and forgot of the fact that I used a 1 in front of the switch prefix, so it should be 14. So if you look at all the other switches, and when we go to switch number 1 and run the CFM, the show CFM SPBM command, you'll see that it will be 11. So being the person I am, and the fact that, I want to show, first of all, I made the mistake, and second of all, I thought, well, I could just fix it on the back end and move forward, but then I thought, no, let me show how easy it is to fix. So what I did, once I discovered what I had done, is I went in and I basically disabled CFM. Then I went in and I assigned a new MEP ID, and then I basically re-enabled CFM. And if we rerun the command of show CFM, we will see that we are now MEP ID 14, and that's a beautiful thing. Okay, so here we go. Let's telnet over to switch number 1. And we'll log in and enable ourselves. And let's run that same command, show CFM SPBM. And we can see that we are also enabled at level 4, which is the default, and our MEP ID is 11. Keep in mind, again, this is secondary. We could all be 1. It doesn't make a difference. But the important, obvious aspect is the BMAC identifier, or the ISIS system ID. So once we have that, we can kind of do a little bit more investigation to the CFM environment by saying show CFM and then the maintenance domain. And this shows 2. We have the CMAC, which is level 6, which is the default for Fabric Connect, and that is not enabled in this environment. We have SPBM, which is level 4, which we know from our previous videos that we've enabled and have functioning. So let's do a little bit more look at this and say, okay, well, obviously we're talking to a maintenance endpoint that is functioning. So what do we have within this information base? And there we go. We see that we have our list of the maintenance endpoint configurations and the association names. And through the previous videos, you will recall these are our VLAN IDs. And you'll see that all of the VLAN IDs are pretty much defined to the CMAC domain, which are on the UNI side, except for BVIDs 41 and 4052, which we know are our BVIDs for our Ethernet substrates within the Fabric Connect cloud. So these are really where we're going to be focusing on. If we go further, we'll see that we have a different domain interpretation, but we still have this concept of the CMAC versus the SPBM. So you can see that we're pretty much going to be focusing on the BVIDs, 4051 and 4052, in these exercises. Okay, now there are 2 commands that I said we're going to do. One of them is an L2 ping. And the first thing we'll do is we'll try an L2 ping, and we'll use the VLAN, which is the primary VLAN. And then we will specify our destination. And I know that looked kind of onerous in the slide, but you don't have to use the full router node name CLI command. Here we're just saying ROU. And then our router node name, which we know is switch 3. So from switch 1, we're going to execute a layer 2 ping across the primary BVID to switch number 3. And we can see that that comes up as successful. We can alternately do the same thing by replacing that value with 4052, which we know is our secondary BVID. And that also works as well. So that's good. We show we have connectivity across both backbone VIDs, and we're able to discern the fact that we have true connectivity over the fabric using CFM. Note that we kind of did the same thing when we did some of the show commands, and that should correlate. Also notice that we pulled a lot of information out of the ISIS link state database. We should be able to correlate all of this information against these CFM exercises that we're using right now. Now, while we know we have connectivity, we really don't know the extent or the details of the paths that we are taking, and that is really where the L2 trace route command comes in. And here we're just going to change our syntax, and we're going to again select the primary VID and say that we want to say ROU, the router node name, and switch number 3. And let's see what we get. And this takes a little bit more time because we have the maintenance endpoint and the maintenance intermediate point and then the maintenance endpoint, and they all respond to give us this total end scope function. So this is specific that I talked about diagnosing the trunks, diagnosing the Ethernet switch paths. And here we see some details on the Ethernet switch path behaviors based on BVID 4051. And as we can see on the primary BVID between switch 1 and switch 3, the primary BVID takes switch 2, which means all odd-numbered L2 VSNs will take this particular path. If I run that same command against our BVID 4052, we will see exactly the opposite. And again, we'll wait a second for the responses of the complete diagnostic train, but we will find that we're going over switch 4. And so all even-numbered ISIDs, or L2 VSNs, will be following this path. And we've seen that in previous videos. So that's a great thing. We've been looking at the L2 information, and this gives us quite a bit of information at the layer 2 level as far as Ethernet switch path behaviors and what's happening. But we can also, ironically, use the L2 ping variable against things like the IP address. So let's try an L2 ping against an IP address, and let's pick something that we know, which would be the management interface of switch number 3, which we know would be the 10.1 network, and that would be 10.1.0.3, because we know this is switch number 3. And we have a completion of it, and we can also see that it's happening over VLAN number 3, which, as we know, is our management VLAN. So our management interfaces, we can see that we can ping into that information. But if you will also recall, we had that 10.10 network. So let's try that. Let's ping the default interface of the 10.10 network, and we can see that there are 2 paths here. And the reason why is because I don't have an ISID associated with it. There is no selection, so it's just an edge VLAN on the network, and you can see that we have 4051 and 4052 running, and they are part of the GRT. They are part of the IP shortcuts, so they're using equal cost multipath. So again, we can tease quite a bit of information given this CFM dialog. So let's kind of extend this and say we want to do a trace route against that same interface. Now what happens is we have equal cost multipath, and we have 2 separate paths of CFM behavior. And we can see that the feedback via 4051 and 4052 gives us our expected information. Switch 1 to 3 via switch 2, and switch 1 to 3 via switch 4. So this is great. And I want to emphasize this is a very simple topology, but everything that I'm showing here would be the case in a more complicated topology. Now, the last thing I want to do is show the ability to run an L2 ping, and I'm going to do something a little different here. I'm going to ping one of the customer networks that we have running inside the IP VPNs. So we're going to take a ping of 30.1, which, as we know, is the default interface for the vidserv VRF. So we will specify that we want to do this within the scope of VRF vidserv. And this is great. It shows that we have switch 3. The next top, we have BVID 4051, 4052. We have equal cost behaviors. So that shows that we have success in that command. The last thing we want to do is obviously run the tracer out command using the same. And I don't need to tell you exactly what we're going to see as a result. And that is the path behaviors over BVID 4051 and 4052. Note that it takes a little longer for the trace route because we have the map interchange of information. So this kind of brings us to the end of the video. This gave us a lot of information as far as what's going on between switches 1 and switches 3 for the different services. We were able to extrapolate that information from the show commands and the various provisioning exercises that we did throughout the video series. So by now you should have a very good crystal understanding of how Fabric Connect works and what to expect when you provision different services within the network. Thank you very much for following this series. I've had some really good comments on this. I apologize that some of them were a little bit noisier than others. I'm in a lab environment, so that's a tricky thing to take care of sometimes. But I appreciate your patience with me as I get things perfected. You will see additional videos as we move forward that will be kind of ancillary to this initial series. But by now, if you follow all of the videos that you've seen, you will be able to set up and enable a Fabric Connect node and enable every single Fabric service and be able to diagnose them. Thank you for your time. This is Ed Kohler again with Extreme Networks, and have a great day.